Uranus occupies a distinctive and fascinating position in our cosmic neighborhood, characterized by unique orbital and rotational properties that set it apart from other planets. As the seventh planet from the Sun, Uranus stands as a distant ice giant that challenges our understanding of planetary evolution and dynamics. The planet's extreme axial tilt, considerable distance from the Sun, and peculiar orbital characteristics contribute to its exceptional status within our solar system. Understanding Uranus's position requires examining not only its physical location in space, but also its astronomical properties, historical discovery context, and its relationship with other celestial bodies in our solar system. Uranus occupies the seventh position in our solar system's planetary sequence, placing it beyond the orbit of Saturn and before Neptune. This ice giant orbits at a considerable average distance of approximately 1.8 billion miles, 2.9 billion kilometers, from the Sun, which is more than 19 times farther than Earth's orbit. This vast distance means that sunlight, traveling at 186,000 miles per second, requires 2 hours and 40 minutes to reach Uranus from the Sun. The planet's orbit is not perfectly circular, but slightly elliptical, with the difference between its minimum and maximum distance from the Sun being 1.8 AU, astronomical units, which is larger than that of any other planet, except for dwarf planet Pluto. At its closest approach, perihelion, Uranus reaches about 18.64 times the Earth-Sun distance, while at its farthest point, aphelion, it extends to approximately 19.75 times the Earth-Sun distance. This considerable orbital radius results in extremely diminished solar radiation, with sunlight intensity at Uranus being merely 1/400th of that received at Earth. The vast distance of Uranus from the Sun results in an extended orbital period that spans generations on Earth. Uranus completes one full orbit around the Sun in approximately 84 Earth years, 30,787 Earth days. This lengthy revolution means that since its discovery in 1781, the planet has returned to its discovery point northeast of the binary star Zeta Tauri only twice, once in March 1865 and again in March 1949. The next return to this position is expected in April 2033, which will mark just the third complete orbit since humans first recognized Uranus as a planet. The extended orbital period of Uranus provides astronomers with opportunities to study long-term planetary dynamics and orbital evolution in the outer solar system. Interestingly, Uranus's orbital elements were first calculated in 1783 by Pierre-Simon Laplace, and discrepancies in its predicted orbit later led to the discovery of Neptune, further highlighting the interconnected nature of planetary positions in our solar system. Perhaps the most remarkable aspect of Uranus's position in the solar system is its extreme axial tilt. Unlike most planets, which rotate with their axis roughly perpendicular to their orbital plane, Uranus has an axial tilt of approximately 82.23 degrees, or 97.8 degrees, depending on which pole is designated as north. This means that Uranus's rotational axis is nearly parallel to the plane of the solar system, causing the planet to essentially roll on its side as it orbits the Sun. This unusual orientation results in extraordinary seasonal variations unlike any other planet, with each pole experiencing approximately 42 years of continuous sunlight followed by 42 years of complete darkness. Near the equinoxes, Uranus's equator faces the Sun, creating day-night cycles somewhat similar to those on other planets, but with the Sun appearing very low on the horizon. The planet completes one rotation around its axis in approximately 17 hours and 14 minutes, making a Uranian day about 71.8% of an Earth day. In the hierarchical arrangement of our solar system, Uranus stands as one of the 4 outer planets and one of the 2 ice giants, along with Neptune. With an equatorial diameter of about 31,163 miles, 51,118 kilometers, Uranus is the third largest planet in our solar system, following Jupiter and Saturn. To put this in perspective, approximately 4 Earths could fit side by side across the face of Uranus. The planet's considerable size combined with its distant position gives it a unique place in our understanding of planetary formation and evolution. Unlike the rocky inner planets, Mercury, Venus, Earth, and Mars, or the massive gas giants, Jupiter and Saturn, Uranus represents a distinct class of planetary body with a composition primarily consisting of water, methane, and ammonia, in what astronomers term as ice or volatiles. This compositional distinction further emphasizes Uranus's position as a transitional object between the massive gas giants and the more distant ice worlds of our solar system. Uranus's position in our understanding of the solar system has an important historical dimension. The planet was discovered by British astronomer William Herschel on March 13, 1781, making it the first planet discovered with the aid of a telescope. Prior to this discovery, the known solar system extended only to Saturn, which is visible to the naked eye. Although Uranus is technically visible without telescopic aid under ideal conditions, its dimness prevented earlier civilizations from identifying it as a planet. The identification of Uranus expanded the known boundaries of our solar system and fundamentally altered astronomical understanding of planetary systems. Initially, Herschel attempted to name his discovery Georgium Sidus, after King George III, but the astronomical community eventually adopted the name Uranus, suggested by Johann Bode, to maintain the tradition of naming planets after classical deities. Uranus's position in the solar system is defined by several distinctive characteristics: its status as the seventh planet from the Sun, its considerable distance of approximately 19 astronomical units from our star, its extreme axial tilt that causes it to rotate on its side, and its 84-year orbital period. These properties combine to create a world with unique seasonal patterns and astronomical characteristics unlike any other planet. As one of the ice giants, Uranus occupies an important transitional position between the gas giants and the outer regions of our solar system, providing valuable insights into planetary formation and evolution. While Uranus has only been visited once by spacecraft, Voyager 2 in 1986, the planet continues to fascinate astronomers and planetary scientists who hope to return to this distant world for further exploration in the future. Understanding Uranus's position in the solar system not only enriches our knowledge of this particular planet, but also contributes to our broader comprehension of planetary systems and the forces that shape them.